There are also a lot of good problems we can get from graphs. So let's look at problem number 4. We're going to do a bunch of parts on this. So the velocity of a particle is given by the graph. And here's this right here. And our first problem is, what is the acceleration of the particle at time t equals 3? So the key things to remember here are that acceleration is the derivative So acceleration is the derivative of the velocity, and the derivative is the slope of the curve at that exact point. So when we go up here to where time t equals 3 right here, what we want to do is we want to say, what's the slope of this line? Well, this curve is flat, the rise is 0, so it's a slope of 0 right here. So our acceleration is simply 0. If we had said, what is this acceleration at time t equals 1, we would have said, what's the slope right here? And then we would have done rise 1, 2, 3 over run 2. But because the curve is flat at t equals 3, so the slope, acceleration, is 0. There are a bunch more questions we can ask with this. I'm going to bring a little graph along for the ride. What is the position at time t equals 4 if the position at time t equals 0 is -1? Well, we know from before that position is the antiderivative of velocity. So that means that the integral from, let's see, 0 to 4 of the velocity is position at time t equals 4 minus position at time 0. Now we know when t is 0, position is -1. Position at time t equals 4 is what we're trying to solve for. And the key thing to remember here is that the integral of the velocity from 0 to 4, this is the same as the area under the curve. From 0 to 4. So if I come over right here, I'm looking for this area from here to here. So this, let's see, that's 3 times 2 divided by 2, that's 3. This is 6. If I add that up, the area under the curve is 9. Subtract 1 from both sides, and there we go.